We'll now look at the consequences of autocorrelation. The first one is that OLS estimators are still linear and unbiased. This is very much similar to the case in the heteroscedasticity, but per se not a consequence, but something that we must recognize, that autocorrelation does not affect the linearity of the parameters as well as their unbiasedness property, but they will no longer have the minimum variance. That is, their the standard error, or rather I would say the variance of these parameters, beta 1 had b1, beta 1 had beta 2 had, or small b1 small b2, they'll no longer have the minimum variance property. So in that sense, OLS estimators are no longer blue, and that's the first consequence, by the way. Estimated variance of OLS estimators are now biased. This means that standard error of OLS estimators, um, the standard error of OLS estimators is truly underestimated, which inflates the t-value, and hence we may wrongly reject the null hypothesis. Hence usual t and f tests are no longer reliable. So it's pretty obvious that when we are conducting the hypothesis testing. So let me just write a t-test here. For example, b1 minus b capital B1, which is the true parameter, over standard error of b1. So if this expression, standard error of small b1, if this is biased, this is nowhere close to the true standard error, then in that case naturally your t value is no longer reliable. Okay, and if that is the case, you can no longer rely on your t test and the f test as well. What about estimator of population variance? Well, it turns out even that is also a biased estimator. And naturally, if the estimator of population variance becomes a biased estimator, that is your sigma ei square over n minus k, where k is the number of parameters to be estimated. This is the estimator of population variance, also known as sigma hat square, or even s square. Gujarati calls it sigma hat square. I think Duharty calls it small s square. If it becomes a biased estimator, then the r square is also no longer a reliable measure of the true r square in the model.